Alright, in this video, I'm going to show you how to create... Wait a second. Do we go to the intro? Oh my god. Let's go to the intro. In this particular video, you're going to learn how to create a free energy video. No. How to create free energy using LED, light emitting diode. Do stay to the ending of this video to get great insight and full tutorial. I'm Second is my name, and watch to the end to judge my video. Thank you. Now I know you're gonna be asking me why the sudden free energy videos. You know what? I got the idea from a member on my Patreon. That is why it's good to join my Patreon. Check in the link in the description below to get to my Patreon and join immediately. I got the idea from a member to make a free energy generation using the LED. You're gonna love this video, dude. Stay tuned. It's fantastic. Now you're gonna be asking me what is a LED. Now actually a LED stands for light emitting diode. Actually, a LED is actually used in different devices like indicator LED, power banks, and other electronic appliances to indicate something or to shine. Actually, everybody know, all electronic enthusiasts know that a LED can be used as an indicator in any electronic gadget. But in this video, we're going to be talking about the dark side of a LED. A LED can be used to generate electricity. Do you know that? No, you don't. So stay to the ending of this video to get going inside. Now you're going to say what is the definition of a LED. Actually, a LED is a light emitting diode which is capable of shining light when electric current passes through it. But do you know that you can be able to generate electricity by shining light on it? Like in a reverse way. Like normally you need to force in electric current to the LED for it to bright out, for it to shine out. But if you facing light on the LED, it will literally produce electricity for you, and that is what we're going to be doing in this video. And that is why I said it's actually a free energy. It's just some kind of, we're going to be using the sun to test it, and also we're going to be using artificial light also to test this circuit. Now you're going to be asking me how this actually works. Now the LED received light and generate electricity through the photo effect, the photoelectron effect. Now when light shine on top of the LED, now this is a normal LED which I'm going to be using in this video. This is a normal LED which I'm going to be using in this video. Now when light shines on top of this LED, it reacts with the electrons on the semiconductor inside the LED, thereby creating electricity out of the terminals which you normally use to power the LED. So that is how we're going to be using it to create electricity. I say normally this kind of project are not really efficient and cannot be able to power large appliances, but we are just making this experiment just for learners that want to learn more about these LEDs and everything you need to know about generating electricity with LEDs. I say again, this is inefficient, so we cannot be able to power some kind of motor, some kind of things. It's just for experiment. So as I said earlier in the last clip, when light faces on top of the LED, it excites the electrons which are on top of the semiconductor, thereby producing electricity which can be measured by multimeters, and some kind of little amount of current depending on the type of LED, the color of the LED, depending on how it can produce current. But I want you to just know that this circuit or this illustration or this experiment is inefficient. Can be able to power large appliances. Maybe if you want to connect a lot of LED, like 1000 LEDs, can be able to generate maybe just 10 amps, but it's inefficient, really inefficient. So without wasting much time, let's go to my decks where I'm going to be talking about how I'm going to be connecting the LEDs. But I'm not going to be using one LED. Firstly, I'm going to be using one LED, then also I'm going to be connecting some kind of series of LED in series to see how much voltage it can produce for me, and also how much current it can produce. Let's quickly go to that. Okay, now welcome back. Okay, now this is the LED, and this is how a LED looks in real life, and this is how a LED looks in circuit diagram form. If you're connecting it in a circuit project, this is how you should draw it. And these two arrow means actually it's emitting light. It means emission of light. So actually when you connect electricity in these two terminals right here, it emits lights, and that is what these two arrow means. And the longest pin of the LED is actually the positive, and the short pin is actually the negative. So this is how it is going to work. As I draw, as you can see, it is actually the sun. This is actually the sun which I draw here. So when light flashes on top of the LED, it produces electricity at this point. Yeah, depending on the kind of the intensity of the light, depending on how it's going to produce the electricity, and also the produced electricity depends on how much the LED draws. Let me say this LED is a 1.5 volt LED and it draws about 10 milliamps. If you shine light on it on the same intensity which it shines out, it's not really going to produce that same amount of current which actually draws, because it's actually inefficient. So just get that in your mind. If your LED is actually 5 volts, or if your LED is actually 1.5 volts on 10 amps or 10 milliamps, don't expect it to produce that exact amount of milliamps which is actually collect when you're powering it with battery. So this is how a LED looks like. Without wasting much time, let's make the connection. These two terminals are going to be connected to my multimeter, and if you want to increase the voltage, you can connect many LED in series to increase the voltage. But if you want to increase the current, you can connect it in parallel. If you don't really know how to connect this, if you don't really know parallel and series connection, go check out the video link below. This is actually it. I connect this LED. I wanted to connect full lot of LED on this very board so that I can have enough power, but because of power failure in my area, I cannot do this. I'll make this video of making the solar panel LED in part 2 of this free energy LED video. So for now, I'm just going to be testing it on my breadboard, and also the current and the advantages. Then in my next video, I'm going to be making the solar LED circuits. Let's go into it. Okay, now so this is the LED which I'm going to be testing in this video. This is actually a 1.5 volts 10 milliamps LED. It's actually a yellow LED, because the yellow LEDs are much good for producing electricity, are much good. So if you're producing this circuit, or you want to use this LED, lots of LED to produce electricity, do use a yellow LED, because the yellow LED produce much higher current on my observation from tips from videos and other things like that. So this is the breadboard which I'm going to be using to make the connections. Firstly, I'm going to be testing this one LED. So I'm going to connect this two terminals to my multimeter. I'm going to flash some kind of light on top of it, and let's see how much it. Okay, I think everything is connected successfully. Connected to my meter, positive and negative. Like I'm going to turn the meter to millivolts. Okay, and firstly I'm going to be testing the LED with the normal intensity, normal brightness of the day, and let's see how much current. Oh my god. Okay, it produces around 100 millivolts, 63, 59. Okay, let's flash my phone light on the LED so to get more brightness, and let's see. Okay, it's going to 100 and 900, 200 millivolts. Wow. Let's flash my light and see. Okay, so this is the Infinix Hot 12 Play light. Let's test it out. Oh my god, it's making noise. It's actually over limits. Let's put it to the normal volt calculation. Okay, check it out. When I place the light on top of the LED, we have about 1.5 volt, 1.3, 1.4. Wow, that's enough. But the thing is, it produces voltage, but the question is, do it really have a lot of current? No, we don't. So to get a lot of current, we need to connect it in parallel together to get enough current. To get enough current to be able to power a LED, I'm going to be using green LED to power. I'm going to be powering green LED because green LED seems to draw little current and little electricity with my testing. So let's connect these bulbs like 5 to 3 in parallel, and let's see its reaction. But firstly, let's connect it in series and see. Okay, we have a LED assembled. We have a total of about 1, 2, 3, 4, 5, 6, 7, 8 LED. Yeah, I'm going to be testing 8 LED, and all these LED are connected in series. I'm going to be showing you how I connect it. Okay, here's a sketch on how I connect it. I know it's a little bit dark. I draw the bulb in this way for you to understand it much better. I didn't draw it in a circuit format. So here's how it works. The positive side is actually connected to the negative side. Series connection is positive to negative, while parallel connection is positive to positive and negative to negative. So here is how it works. So the positive side of the LED is connected. I use 3 bulbs just to give example. Positive side of the LED is connected to the other bulb negative. The other bulb positive is connected to the other bulb negative, and the other bulb positive is the output positive, and the first bulb negative is the output negative. So you simply connect positive to negative, then the two ends are the output. So here's how it's connected. Really simple. If you really don't know understand, how parallel and series connection. I say it again, check out the video, link in the description, or check out there. I make the full breakdown video on how to connect this in place. Okay, first off, it's connected in series, so let's see how many volts we can be able to generate from the normal day lightning. It's 105 millivolts. It's small though, because we connected 8 LEDs in series, and imagine that we have about one LED is producing 1.5 volts, two LED will producing 3.3, two LED will producing 3 volts, so this two will be 6, and this two will be 6, and we have 12, and we can have about 13.5 volts. So let's hope to get 13.5 volts when I flash my light on it, and let's see the magic. And look at, check it out. Okay, it was not a success, I'm not gonna lie. When I powered it on, when I faced my torch on it produced a really low voltage than just the one LED produced. So I decided to connect just only 4 bulbs in parallel, and let's see, maybe the too much bulbs draws a lot of power, and there's some kind of power losses, and maybe I need more bright LEDs, more bright light and broad light to bright each of all the lights for me to produce enough electricity. Because that's first time, because I was just using only one LED, I was able to focus all the lightning on that LED. But since it's a lot of lightning, I need a lot of forward light to the LED to create that full electricity. But I don't have that. I have one spare LED, but it got burnt. Don't know, planned for the video, but it got burnt, so I have to use my phone touch. So you know what, I'm going to reduce the LED, and so that I can face the light on small amount of LED and see how much you got. Okay, since my lighting is not enough, I reduced the LED to just 2 LED connected in series, and let's see if the 1.5 volts which one LED produces actually increases. So check it out. When I face it on it, how much voltage do we have? Oh, 3.1. Oh my god. Oh, this is really when I face the light directly into it. We have a voltage increase. Oh my god. Finally it worked. Okay, let's see if it can be able to power these LEDs and see if we can get any current of it, and let's see if our free energy is a success. Okay, welcome back. We all know that the bulb which I want to use to power, is actually a 1.5 volts LED, and the circuit, or the 2 bulbs right here, were able to produce 3 volts, and let's see if it's powered this LED. So I reduced the light lane, so I'm going to face the camera and see if it can be able to power the LED, even a little bit. Let's check it out. Okay, I'm going to turn on my touch, and you just pay attention to this LED which is connected here, and I'm going to face it, the lightning jar. Oh my god, it turns on. Yeah, you can see the green light. You can see the green light. You can see it. Oh my god, it's fading. I don't know if you can see a green light. I saw it before, Chad. The green light, you can see the green. Oh my god, it worked. Oh my god, it worked. It actually powered the green LED. Oh my god, this is the power of solar, chat. This is the power of solar. It worked. Oh my god, I can't believe it actually worked. The light was really small, but I promise you I am going to join a lot of LED for me to create a full power. Yeah, in my next video about the part 2 of this LED, I'm going to be joining a lot of LED in parallel and series to create enough energy and to power some kind of toaster or some kind of calculator and see if it really works. So I think we're done with the project, and it works perfectly, and not really efficient, but it's really a science experiment, and I hope you learned something new. So to close this version, is this free energy? Nah, this is not free energy. This is solar energy. So without the light, without my phone light, it's not going to generate electricity. Without the day, it's somehow like electricity. It's somehow like free electricity, because we are not going to generate the sun, or we are not generating the daylight. It's somehow like free energy but it's not practically like a free energy generation, because if the place is dark, it's gonna be able to produce electricity, and we need to turn on a light, and that light we're gonna use it some kind of power battery to turn on that light to face to the bulbs to generate power for us. But if it's the normal day, the normal sunlight, you can be able to use it. So it's somehow like a free energy, but it's not really practical free energy. Anyways, thank you very much, and I will make a full video talking about how to connect this full LED and make a lot of current out of this LED circuit. I hope you're really gonna enjoy that, and just go to the conclusions. So there you have it, free energy with LEDs. Yeah, it's inefficient. It's gonna be able to power 2 stars or a lot of things. It's inefficient, chat. You can try this experiment at home and make it, and let me know in the comment section if you love this video, and also support me on Patreon to get full breakdown, more tutorials, and more video description on the Patreon. Thank you very much, and I'll catch you guys in the next one. Check on the link in the description. A lot of links there to learn, so see you there.